픽써엘 채널.
안녕하세요, 픽써엘입니다. 오늘은 메카니칼씰에 대한 영상을 준비했는데 아주 유니크한 영상이에요. 저는 10년 전에 이 영상을 처음 봤는데요. 1980년대에 제작된 영상이라서 소품도 클래식하고 화질도 좋지 않지만 메카니칼씰의 작동 원리를 이렇게 감성적으로 표현한 영상은 아직 보지 못한 것 같습니다. 그만큼 완성도가 높다는 얘긴데요. 바로 함께 보시죠.
A housing and the shaft. Fluid is stirred, pumped, centrifuged, or treated in some other way within the housing. It's the shaft that initiates the rotary motion. The gap between the housing and the shaft has to be sealed. That's obvious. But now the shaft will no longer turn. Rotation and sealing. Can they ever be compatible? Here, the shaft requires clearance so that it can rotate. Seal faces not parallel with, but rather perpendicular to the axis. That's the answer. The housing and the shaft boss form the seal faces. Good support is essential for the proper performance of the seal. But will the seal withstand higher loads? The seal starts leaking due to wear caused by friction. The shaft and housing are far too expensive to be used as wearing parts. Ideally, only the seal faces should be changed. A stationary seat at the housing, a seal face on the shaft. Exchangeable wearing parts make it possible to optimize the various available materials. Here, the seal is perfect. But here and here, we still have a leakage path. Of course! Instead of one sealing gap, there are now three. No wonder there's a drip. Because seal and seal face rotate at the same speed, they don't move in relation to each other. Between the housing and the stationary seal face, there is also no movement. And if nothing moves, sealing is no problem. Secondary seals are used. Wear cannot be totally excluded, but it can be compensated. With a spring, for example, which presses the sealing face to the stationary seat. Here we have it, the mechanical seal with its 5 components. Rotating seal face with secondary seal and spring. Stationary seat with secondary seal.